Tonight opens like a postcard from the dark. The house is quiet, the screen is dim, and somewhere above the roofline, a soft river of stars drifts east to west. I'm here with you, speaking low and even, to tell a bedtime story about two wanderers in our sky, and the calm, patient science that follows them. If you're listening in bed, settle deeper. Let your shoulders drop. Turn on Do Not Disturb. If you're driving or operating anything that moves, press pause and come back later. For the best experience, lie on your side, slow your breathing, and let your eyelids grow heavy. We'll move gently, never rushing. I'll describe what astronomers observe, then ease each idea into simple images you can picture with your eyes closed. A visitor named 3E Atlas will be our main lantern. A second, fainter newcomer will appear along the way. I won't hurry you through charts or jargon. I'll trade them for textures, distances turned into feelings, and a steady rhythm you can trust. For a fuller night, follow the playlist so this episode flows into the next while you sleep. If something calls to your curiosity tomorrow, you'll find it waiting. Calm facts, soft metaphors, no alarm. Take a slow breath. Imagine the night sky as a lake without wind. A thin glow rests where the shore would be, and far out, two dim boats move along their quiet courses. Nothing threatens, nothing demands, only motion and light and time. I'll keep watch, you can rest. When you're ready, we'll step to our first scene and let the story begin. It's late, the kind of late that folds edges off the day. A small clock glow rests on the nightstand, and the room hums with the soft machinery of sleep. Outside, the sky is inked and steady. I write a little postcard to mark our beginning. A calm hour, a cool window, and a visitor far beyond the roofline, moving not in circles, but along a path that simply passes through. We call it a V1 Atlas. I'll speak gently, and will let the facts move at the speed of breath. Astronomers care about paths the way river pilots care about channels. A planet loops the sun like a boat tethered to a post. A comet from our own deep cloud will still curve homeward, its long ellipse bending back toward daylight. An interstellar traveler is different. Its track is unbound, a long sweep that arrives from the dark, grazes sunlight, and keeps going. I picture it as a river pouring past a bend, no retained eddy, no turnabout, just a smooth glide onward. That shape tells us a lot. It says this wanderer isn't tied to here. It says we will watch, then wave as it drifts on. Before a name, there is a signal. Wide-field surveys scan the sky each night, comparing new frames to last night's quilt and the night before. Pinprick by pinprick, motion reveals itself. The first hints are small, a dot that shifts against the fixed grid of stars, a brightness that doesn't match the catalogue, a whisper on the sensor. Teams stack images to catch the faintest trace. A report goes out. Measurements repeat. The minor planet center gathers those threads, and a path begins to sharpen. It's patient work, and that patience soothes the mind. Distance is the other half of comfort. We measure it in astronomical units, the span from Earth to Sun. If you imagine the Sun as a hearth and Earth as a chair beside it, an astronomical unit is the reach of warmth across that room. When we say a thing is many times the moon's distance, it feels far. When we say it lives in units of the Sun-Earth span, it is farther still, deep water far. Comets and interstellar guests alike do their dancing at scales best counted that way. For sleep, that's a simple promise. these stories unfold at calm distances. What, then, is a comet in the gentle sense? A small nucleus, dark as a pine cone, waking as sunlight loosens ices. Gas lifts dust, a hazy envelope forms. This coma, a quiet halo. The tail does not trail behind the way a scarf trails a runner. It points away from the sun, pushed by light and a wind of particles. Sometimes a second, straighter tail of ions stretches like a fine filament. Under certain angles, the geometry can fool the eye. A spike may seem to lean sunward, though it remains a dance of light, dust, and perspective. If you hold that picture softly, it will serve you all night. To predict where a visitor will be tomorrow, we take fresh measurements tonight. Each observation is a waypoint on the chart, like placing beacons along a river. Here at midnight, here at dawn, here again under evening's first star. Fit the points to the curve, account for the whispers of planets, and the track refines. The process is not dramatic. It's mostly quiet mathematics and check logs, the kind of work that pairs well with still air and a low heartbeat. And when the path is sure, anxiety has nowhere to live. I like to think of the sky as a ledger that keeps its own calm. The bright constellations provide the headings, the instruments fill in the rows, mirror diameters, exposure times, wavelengths. Yet none of that needs to keep you awake. You can just carry the images, a dome opening with a sigh, a sensor cooling to crystal hush, a team watching a line of numbers accrue like dew on grass. There is trust in repetition. There is trust in many eyes. We have met interstellar travelers before. One came as a shard with no visible coma, the light curve flickering as it tumbled, then gone beyond our retinas forever. Another arrived with a classic envelope and tail, a true comet from afar, its chemistry surprisingly familiar. Taken together, these taught us to expect variety and to be humble. A third visitor does not need to behave like either of the first two for our story to stay simple and sane. The sky holds room for patterns and exceptions. It always has. If you find your thoughts quickening, return to the scale picture. 1 unit from us to the sun, the moon, a thumbprint by comparison. Most encounters we discuss lie many moons beyond us. Most measurements we quote refer to spans that your mind could treat like long, slow coastlines. Our language may mention kilometers, but our meaning is far and getting farther. Let that be an exhale. Let it soften the edges of the day. So we begin our map the way river pilots mark their first page. A date, a time, a level of the water. The visitor is out there, on a course to skim the inner reaches and continue on. We're not here to chase, only to observe, to learn what steady watching can teach, and to sleep better for having placed the beacons. The night is wide, the halo is quiet. We will take our time, and all is well. Listen for a moment to the room. A low fan turns. Somewhere beyond the window, a moth taps the glass and then forgets. In that hush, picture a small dark seed drifting into sunlight. The light is gentle at first, then it grows. Ice loosens, vapor breathes out, and a faint fog gathers round the seed like mist cupped in 2 hands. This is the coma, soft-edged, a lantern in thin air. Dust grains ride the gas, and the lantern brightens, not loudly, but with the patience of warmed stone. When people say a comet has a tail, they often imagine a scarf trailing behind a runner. The truth is calmer. The tail points away from the sun, not away from the comet's motion, nudged by sunlight and by a steady wind of charged particles that flows outward from our star. Some nights, the dust tail is the one you notice. A pale fan, curved, easy to love. Other nights, the ion tail steals the scene, slim and straight like a pencil line, shaped by magnetic fields carried in that solar wind. Either can be shy, either can be bold. Brightness grows as a traveller nears the sun. More heat means more lifting of gas and dust. But the change isn't a light switch. It follows distance, surface character, and how much fresh ice is exposed. Within the coma, sunlight scatters off particles a few microns across, and the whole halo can swell to many thousands of kilometers, even while the solid core remains only a few kilometers wide. Geometry adds another layer. If the tail angle's nearly along our line of sight, it seems shorter. If moonlight raises the sky's floor, the dim parts of the tail can hide in that glow. Color has stories to tell. A gentle green sometimes blooms when molecules called swan bands of carbon light up in the blue-green part of the spectrum. A chalky blue can belong to ionized carbon monoxide or other charged fragments swept into that pencil-thin tail. Sodium can paint a faint yellow. Water's daughter, hydroxyl, sings in radio bands, and simple cyanide casts a violet whisper that cameras record better than eyes. None of these hues imply drama. They're chemistry, doing what chemistry does under sunlight. Tiny beacons that help observers sort dust from gas, source from result, near from far. Perspective is a quiet magician. If Earth lies close to the comet's orbital plane, dust laid like breadcrumbs along the path can line up from our viewpoint and form what looks like a spike angled toward the sun. It isn't a jet driving upstream, it's an edge-on slice through a sheet of grains, a ledger held sideways so the pages seem one. Add the practical world, low altitudes that thicken the air, wind that ruffles long exposures, a bright moon that pours silver into every shadow. And you have a recipe for nights when telescopes toil against the horizon and the clock, stacking many short frames into one careful picture, while astronomers whisper to each other about humidity and guiding, and when the roof will frost. Instruments help the eye. Big mirrors like those on mountaintops collect the faintest brushstrokes. Smaller amateur scopes, sturdy and beloved, gather their own truths from suburban backyards. A photographer might stretch a stacked image to bring out structures sitting just above noise, then gently blur stars to accent the comet's delicate flow. Spectrographs split the light and measure which molecules glow most tonight. Polarizers tell whether dust grains are coarse or fine by how they twist the plane of light. None of this needs to keep you awake. It is simply how a lantern in mist becomes a map. Sometimes a report says no clear tail under difficult conditions. That does not mean no physics is happening. Gas can be present though faint. Dust can be coarse and reluctant to drift far, or the tail can lie nearly along our sight line. Photometry, measuring brightness through fixed apertures, still sees change. Profiles drawn from the center outward still widen with activity. Time-lapse still shows a small, steady shift across the star field as the traveler keeps its appointment with dawn. The lantern's heart glows even when its veil is thin. For sleep, let the mechanisms blur into an image you can keep. Imagine a handheld lamp on a quiet shoreline. Around it, evening mist slowly thickens, taking a tint that slides from green to pale blue as the breeze changes. Some moments the beam spreads, soft and fan-shaped. Some moments it narrows into a straight ribbon over water. You don't need the formulas to know the weather of light. You can just watch and breathe. The soft green trace returns again and again, as if the sea itself remembered a song. All of this is ordinary in the most beautiful sense of ordinary. A small body warms, ice loosens, vapor escapes, dust goes with it. Sunlight pushes and geometry edits what we see. Telescopes, large and small, do their patient work, and people compare notes in the morning. We will do the same. We will let the pictures arrive, and we will welcome the nights when the tail stretches like a banner, and the nights when the lantern keeps its glow close. For now, let the image dim gently, as if fog folded in around the lamp and the shoreline exhaled. Fade with it. What does a comet sound like if you listen with radio ears? Not a melody, not a voice, but something quieter. A notch in the noise, a pale note in static that tells of water meeting sunlight. I ask softly, because the answer arrives softly. It comes as two narrow fingerprints in the spectrum, tucked where radios measure with steady patience. In South Africa, an array of white dishes called meerkat turned towards the place where our visitor moved close to the sun. The team listened in the 18-centimeter band, where hydroxyl, the fragment born when ultraviolet light splits water, leaves its signature. At 1 magsync 65 and 1.667 gigahertz, they found it, not as a flare, but as absorption, the coma's thin gas taking a sip from background radio glow. That sip shows up as a dip. It is enough. It is exactly what a natural, sun-warmed comet should do. Hydroxyl is the reliable child of water under starshine. Photons in the solar ultraviolet strike H2O, bonds loosen, and OH spins away as a separate radical. For decades, astronomers have used these lines to infer water production in comets from our own Oort cloud. The physics travels well. Interstellar or local, ice under sunlight makes the same small family. We measure, we compare, and we let the chemistry speak without drama. Timing added tenderness to the result. This listening happened near perihelion, when the comet skimmed its closest point to the sun and the sky around it blazed. The angular separation was only a few sun-widths, difficult for optics, challenging even for radio. Yet the array resolved the lines, and with them a neat Doppler shift that traced motion along our line of sight. In the spectrum, speed is just a nudge left or right, a tuning fork tilt of the note. The pale note in static became a measured breeze. Absorption is a shadow more than a shout. Imagine a thin curtain drifting in front of a softly lit window. The fabric steals a little brightness. The room notices. That is what Meerkat saw. The OH in the coma dimming a slice of the background field. The depth and shape of the dip carry information about how much OH is present and how it moves. The exact radio frequencies, the 1665 and 1667 megahertz pair, act like matching prongs on a tuning fork, confirming that the curtain really is what we think it is. If you heard the news described as a radio signal, it's easy to picture beacons or deliberate messages. The kinder picture is simpler. This is sunlight doing work, molecules doing what they do, instruments carefully measuring. It is the same way we listened to many comets before. An 18-centimeter whisper that says water is being made and unmade here, that the coma is alive with ordinary processes, that a traveller from beyond our system behaves in a way that fits the patient catalogue of all comet behaviour. The comfort in that is practical. Those two little lines let researchers estimate how much water the comet sheds per second, how activity rises and falls as distance changes, how streaming atoms and ions paint the ion tail we cannot always see. The figures are not needed for sleep. What helps is knowing the method is sound and the measurements repeat. Night after night, receivers collect threads. Morning brings a woven strip of data that looks like a shallow valley where a flat field used to be. Radio arrays work like quiet choirs. Each dish sings a part. Together, they resolve finer detail than any single dish could manage. Signals meet in a correlator that times their arrivals to a heartbeat finer than a blink. A spectrometer then stretches the light into narrow lanes, each only a few thousandths of a percent wide. The OH lanes sit where textbooks say they should, and the comet's motion slides them by a small, precise amount. The result is as modest as a pencil mark. It is also definitive in its modesty. For you and me trying to rest, there's an easier image. Picture a metal tuning fork touched gently to a wooden tabletop. A cool vibration settles into your fingers. Now place that fork underwater. The sound blurs and softens. Energy goes into the fluid and fades. What Meerkat's recorded is a chart of that softening. Energy lost at 2 expected pitches because the space around the comet holds the right kind of molecules. A pale note in static, a reassuring blur. Observing so near the sun challenges more than optics. The radio sky is full of human signals, of storms from our star, of reflections and drifts. Teams subtract, calibrate, and wait until noise becomes a manageable sea. The detection stands because the pair of lines appears together, because the Doppler shift matches the comet's ephemeris, because the depth is consistent across multiple pointings. Quiet confidence grows out of these cross-checks. Confidence, then sleep. Perihelion passed, and the object began to pull away from glare into darker, friendlier fields. The OH lines will evolve as it cools. Other instruments, optical, infrared, will add their stories from mountaintops and from space. Still, I like that radio came first for water. It feels right that a thing too hot and too bright to stare at directly could be known by the gentler sense, by a measurement that doesn't need starlight, only patience and a well-tuned ear. So we take this as a small anchor in a big, quiet sea. The third interstellar visitor carries ice that becomes water, that becomes hydroxyl under our sun. The same law holds here as it holds everywhere. Let that sameness ease your mind. Imagine the spectrum as a slow band of colour, then let the 2 narrow dips dissolve into it, like pale ink into a wash. The page goes smooth again. The note fades. The night returns to steady grey. We'll take a slow zoom tonight, not on a photograph, but on the way numbers knit a path. Think of 2 lighthouses instead of 1, their beams crossing the same patch of dark water. From Earth, we watch a moving dot. From Mars, a second watchman looks back across the gulf. Where those look lines meet again and again across several nights, the track sharpens into something slender and sure, a thin white line we can follow. Until early October, all of our sightlines came from this planet. Telescopes compared frames night after night, and the ephemeris, the predicted where and when, held a comfortable blur. Then the ExoMars Trace Gas Orbiter looked up from its orbit around Mars. Between October 1 and October 7th, the spacecraft turned its Cassis camera away from the red planet and toward the interstellar visitor as it slipped past, closest on October 3rd at roughly 29 million kilometers. The geometry changed everything. With Mars 10 times nearer to the comet than Earth, that second vantage tightened the triangulation. Triangulation is the sailor's friend written in starlight. Mark the object's right ascension and declination from here, mark it again from there, and the crossing threads reduce uncertainty the way a knot tightens under gentle pull. A single observatory's measurement has a cone of doubt. Add a second observatory far away, and those cones intersect in a smaller diamond of confidence. Repeat over several orbits of the Mars spacecraft, and the diamond shrinks again. What was a smudge becomes a pencil line, the thin white line. The result was not just tidy, it was large in the quiet language of precision. ESA reports that fusing the Mars-based measurements with Earth-based data improved the predicted location by a factor of 10. Tenfold feels abstract at first. For a listener trying to sleep, imagine drawing a circle the width of a fingernail to represent last week's uncertainty. Now, with Mars in the mix, that circle shrinks to a bead. Aim a telescope tomorrow night and you point at the bead, not the fingernail. Schedules firm up. Exposure plans settle. Anxiety has less to feed on. There was novelty in the paperwork as well as the sky. The astrometric positions extracted from that Mars orbiting camera were submitted to the Minor Planet Center and accepted. Reportedly, the first time measurements from a spacecraft around another planet entered that global ledger for an interstellar comet. It's a small sentence with a long echo. Planetary defense teams talk often about rehearsals. Here is one that used a tool not designed for the task, repurposed with care, and made the forecast better. The rehearsal matters even when the object is gentle and far. Behind the scenes, this took choreography. The camera aboard ExoMars was built to look down at Mars, not to hold a guide star and collect a faint smear moving against a peppered background. Flight dynamics teams pinned down the orbiter's own motion with the fidelity of a music metronome. Image processors sifted noise, removed cosmic ray specks, and registered frames against catalog stars. Orbit computers reconciled frames from two worlds to a common clock. It's the kind of work you do with soft voices and long breaths, the kind that suits a night like this. Why does a new angle help so much? Parallax is a quiet lever. Hold a thumb at arm's length and alternately close one eye, then the other. The thumb seems to hop against the far wall. Move your head farther apart. Now the hop is larger. Earth and Mars supply a baseline millions of kilometers wide. For something speeding through the inner system, even a short observing window can produce a measurable hop. Convert that angular hop into a refined distance and direction, and every future prediction benefits, like a train timetable updated once the first stations confirm the exact running time. When the line tightens, instruments elsewhere can work more tenderly. A spectrograph slit does not need to be widened as much to guarantee light. A radar dish can time its on-target window more precisely. A small backyard telescope can slew directly to the bead and begin stacking 3-minute exposures without losing minutes to manual sweeping. Precision is not a luxury in astronomy. It is a kindness. It returns hours to observers who have only a few before dawn. It returns confidence to teams who must choose between targets when weather or funding allows only one. There is also the simple pleasure of the GIF that came with the numbers. A tiny, tufted point gliding across the star field as seen from Mars. You do not need to make out jets or structure to feel the weight of that motion. The frame says, "We were there too, watching from another shore." It says our system is wide enough to place beacons in more than one harbour and read their angles back home. It says, quiet collaboration still moves the needle. We are careful to keep the scale serene. Even at its Mars close by, the visitor remained tens of millions of kilometres from anything it could trouble. The improvement in its predicted position does not mean urgency. It means clarity. A thing that will soon sail outward past Jupiter and into the dark again is better known for having lent us this geometry lesson, and the lesson will travel forward. Next time a difficult object skims past the Sun, there may be another orbiter ready to look crosswise and feed the ledger. Hold, then, the picture of two lighthouses and one small boat. The beams do not flash with drama. They simply overlap, then overlap again, until the wake smooths into a line you could draw with a fingertip on dark water. The thin white line. It is enough to guide a night watch. It is enough to ease a mind. Let the brightness on your screen dim a notch, as if the observatory closed its dome halfway to keep dew at bay. Breathe with the rhythm of a long exposure, and let the numbers finish their quiet work while you rest. I keep a small memory for nights like this. A desk lamp turned low, a thermos warm at my elbow, and a finder chart with one faint side glow that wasn't there the week before. A side street off the highway of the main story. That's how a second newcomer entered the map. A modest light, a quiet line in the log, a name that would settle into the ledger as C2025 V1 Borisov. The surname rings a bell because we have heard it before. Gennady Borisov, the careful observer who found the second interstellar visitor years ago, spends long hours with a custom telescope and a practiced eye. In early November, another moving seed appeared in his frames. Its motion fit the patient rules of discovery. A shift against the fixed lattice, a brightness measured, a report filed, follow-up images collected by others. This is how a side street gets a street sign. This is how V1 joined the night. At first pass, orbital elements are a handshake, not a promise. The early solution for V1 carried what we call a near hyperbolic shape, an eccentricity hovering near 1, the border between bound and unbound. Its plane was tipped steeply, a retrograde tilt against the flow of the planets, the way a leaf might skate upstream across a slow canal. Numbers settle with time. Each new measurement nudges the fit, and small errors become smaller. Whether the path proves unbound forever, or only skims the edge of our long Oort cloud, the practical picture tonight is simple. A faint traveller on a steep, high-latitude lane passing through. That steepness and faintness shape how we see it. The nucleus remains only a speck. The coma, thin and shy, spreads a little around that core. On some nights, a stub of tail appears in careful stacks. On others, geometry or glare hide it in the background. None of this is strange. Many comets soften and sharpen as viewing angles change, as moonlight rises or falls, as altitude and atmosphere cooperate or refuse. The story remains a lantern that sometimes holds its veil close. People listening with one ear on headlines may notice another thread. V1 reached its nearest distance to Earth in mid-November, on a course that put it roughly 7/10 of an astronomical unit away, about 100 million kilometers. That is comfortably far, another deep water number. It is also a reminder of scale. Two objects can share a view from our balcony without sharing an origin. Sky maps compress the dome into a sheet. Lines coincide by projection. Space itself is roomy, with depth that hides quiet separations. I trace that separation like this. Picture the main highway as our interstellar guest, 3-eye Atlas, wide and bright in the mind's eye. Now imagine a smaller road, local and narrow, joining the scene from a different quarter. You can stand at a hilltop and see both ribbons of light at once, one sweeping across the valley, the other crossing at an angle. But the drivers do not know each other, and their errands are distinct. V1 lives on that second road in our picture, a faint side glow that appears near the main route only because we're looking down from above. The ledger speaks in letters and numbers. C2025 tells us this is a comet found late in the year. V1 places it in the month. The parenthetical tag honors the discoverer. Early bulletins share a perihelion date, a distance of closest approach to the sun, and then the steady stream of nightly measurements. Ride ascension, declination, brightness, a scatter, as weather and equipment change. These are not the sounds of a proclamation. They are the routine, consoling shuffle of pages in a well-kept book. If you enjoy the way numbers calm the mind, the trio QE repays attention. Perihelion distance, shape, and tilt. Q speaks to how deep into sunlight the comet wanders. E says whether the track closes or keeps going. I tells how the plane of motion leans compared to the disk of planets. With V1, that lean is steep and backward, and the shape sits near the threshold that tempts headlines. But thresholds in astronomy often blur. A fragment kicked from the far cloud can mimic an unbound visitor until weeks of astrometry erase the illusion. The inverse can happen too. What matters for sleep is that telescopes know where to look tomorrow. They do. Discovery was followed by a quick chorus of confirmations. Observatories spread across longitudes placed their own dots, chasing the same faint seed through noisy air and a bright moon. Stacked frames pulled out a delicate haze around the point. Photometry through fixed apertures wrote small rises and dips as the nights turned. Some teams reported a stubby tail, a few arcseconds long, angled by the same rules that sculpt every dust fan, away from the sun, curved by gentle pressure. Others noted only the core and its blur. The variability matches the humble expectations of observers everywhere. Use what the night allows, accept what it hides. I find comfort in how a second object can be folded into the story without urgency. We have room for 2, we have room for 40. The sky at any hour holds near asteroids, far comets, slow planet arcs, and the hush of the Milky Way. V1's presence as a side note doesn't bend the main arc of our lantern on the highway. It adds texture, a reminder that discovery favors those who keep looking even while the world's attention tilts elsewhere. Somewhere, a volunteer stacks 10 more frames. Somewhere, a child at a backyard eyepiece asks why stars don't smear while comets do. Every answer is a small light. If your thoughts start to knit stories from coincidence, lay them gently down beside this simple guide. Shared sightlines are not shared causes. 2 boats can drift on the same horizon line while miles of water lie between them. Dynamics do not care where our eyes happen to be. Orbits obey mass and motion. They do not conspire. That principle is a pillow you can trust. It carries from night to night, from object to object, keeping wonder and restraint in a kind balance. So we let V1 be what it is tonight. A faint, steep-tilted traveller logged in the book, waving shyly as it crosses a wide, quiet middle distance. If the tail lengthens, we'll admire it. If it stays close, we'll read its changes in numbers and move on. Our main lantern continues along its grand sweep. The side street returns to dusk. At the shoreline of this chapter, the glow thins to a pane of silver over water. The waves lift and set the reflection with a slow, even hand. Hush rides the pebbles, and everything slides one shade darker towards sleep. Let's lay out the shoreline together. A calm hand on the map, a pencil ready, and the awareness that names and numbers can be pillows when they are placed with care. I'll give you markers first, then distances you can feel, then one quiet promise about safety. Breathe in for 4, out for 6. We'll keep the cadence slow. First marker, the unit we use. 1 astronomical unit is the span between Earth and the Sun. Think of it as the width of a wide bay on our map. The moon's path is a tide pool by comparison. When astronomers talk in AUs, they are pointing to the big water, the wide blue, where ships keep to deep channels far from shore. Second marker, the visitor's brush with sunlight. In late October, the track skimmed its closest distance to the Sun. That phase has a name, perihelion, and it's when ices wake most readily. After such a turn, most comets brighten, then begin to dim as they drift outward again. This is more timing than drama, a tide rather than a storm. Third marker, the date we like to circle on a kitchen calendar, not because it is perilous, but because it is convenient. Around the middle of December, the visitor reaches its nearest distance to Earth, yet nearest, here, still lives in the wide blue. It's on the order of the bay's full width, and then some, a long quiet gulf measured in AUs rather than moon steps. Telescopes appreciate the geometry. It lifts the object a little higher from the sun's glare. Your heartbeat doesn't need to change, now the distances as feelings. If the room you're in is Earth, and the lamp across the room is the sun, then 1 AU is the space between you and that lamp. The moon would be a fingertip held at arm's length. Comets, when close in the astronomer's sense, still move in rooms larger than houses, many times larger. Visualize a slow skiff passing a lighthouse beyond the far end of a long pier. You see it. You note it. The water between is real and restful. Our words help. Far, farther, farthest. They slow the pulse. They also help you ignore big raw numbers that arrive with too many zeros to tuck under a pillow. Whether we say hundreds of millions of kilometers or we say 1 to 2 AUs, we mean the same thing, deep lanes. You can picture a chart with dark contour curves and wide separations between the lines. The wide blue is not just a color in this story, it is comfort. Timelines can be kind as well. Late October for the sun glide, mid-December for the easiest windows from ground observatories. Weeks of watching before, during, and after. When a map is dated in pencil rather than ink, you sleep better. It invites revision without alarm. Each new observation narrows uncertainty, like the coastline being traced more sharply at dusk. The headlands keep their shapes. The smaller inlets gain a little detail. The sea keeps its hush. The question that sometimes floats up, even when you're sleepy, is simple. Is it safe? Here, the map is firm. At household scales, these distances are enormously calm. The path does not cross Earth's. The gulf remains a gulf. The straight edge from us to the object never shortens to a fingertip. Planetary defense teams practice for quite different cases. Small, near-Earth rocks that require close tracking. Tonight's visitor is a skiff in the outer channel while we stand on shore counting waves. That's it. What do astronomers do with a safe, far visitor? They choose patience, spectroscopy to read composition, photometry to watch the brightness breathe with distance, narrower slits and tighter pointing once the path is refined, a rhythm of dawn and dusk when the sun is low and the sky is cooperative. The middle of December is not a cliff edge. It is a window that opens a little wider for a few nights, then drifts closed again. If clouds arrive, there will be other dawns. If a telescope misses, another will catch the line. Quiet redundancy is part of the craft. Let's bring the map closer to your senses. Trace a coastline with your finger on the bedsheet. Each knuckle is a week. The curve near the wrist is late October. The middle of the palm is mid-December. Farther along, toward your fingers, the line turns away into open water again. You don't need to memorize the geography. You need only the feeling that the curve is smooth and the sea is wide, the wide blue. It waits, patient and unchanged, while our small light moves gently across it. If numbers tempt you to wakefulness, translate them to breath. 1 AU, inhale. Another AU, exhale. A month between anchor dates. 2 slow cycles. A telescope run. The span of a lullaby. When a chart speaks in huge spans, you can answer in small ones. Matching small to large drains the hurry out of thought. Sleep notices and steps closer. A final kindness. The sky itself signals safety in its posture. Objects that threaten cut across the shorelines we know, planet paths, meteor streams, at angles that draw the eye. This traveller's lane is melodious with the system's shape. It rises from the glare, offers itself to careful instruments for a season, and then coasts back into the dim without changing. The lighting on our porch. You could walk outside, see the same constellations you learned as a child, and never guess that a guest is threading the far lanes with a quiet tale and a quiet coma. No surprise is waiting at the door. Only the night and a little more to know about it. So set down the pencil. Roll the map and tuck it at the foot of the bed. The markers will be there in the morning, the lamp that stands for the sun, the chair that stands for Earth, the gulf between in calm units, the dates circled not in warning but in welcome. I'll keep the chart nearby as we move on, adding a lighthouse here, a buoy there, as new measurements arrive. For now, the lantern dims. The shoreline slips into shadow. The wide blue keeps its depth, and you keep your rest. In a courtyard of the mind, a sundial waits. Stone keeps the day, and a single slanted ray edges across the face from hour to hour. Shadows tell time by geometry, not by hurry. Hold that picture because the sky uses the same quiet lesson. A comet's tail is a kind of shadow written in light. It marks where sunlight and the solar wind push, not where the comet chooses to run. Begin at the center. A nucleus sleeps, wakes, and breathes. Gas rises, carries dust, and a round, soft coma forms, close about the core, like breath on cool glass. Beyond that halo, the push of light begins to sort things. Dust grains, born in many sizes, feel radiation pressure differently than gravity. They are nudged outward, and a fan appears, curved like a banner caught by a steady breeze. This is the dust tail. Its shape is gentle, because each grain remembers when it was released. So the fan is a library of moments. widening page by page. A second actor is stricter. Charged molecules are swept into lanes shaped by the interplanetary magnetic field carried by the solar wind. That tail, the ion tail, draws the eye as a straight, narrow filament, often tinted bluish when ions like CO+ glow. Where the dust tail curves, this one aims like a taut string. It does not bend to the comet's direction of travel. It traces the wind's direction away from the sun. Think of two shadows at once, one from a lamp's light, broad and soft on the wall, and one from a wire held in that beam, pencil-thin and neatly defined. Both are true. Both are the same ray, differently told. Geometry can fool kind eyes. If Earth lies nearly in the comet's orbital plane, the dust left along that path can align with our line of sight and form what observers call an anti-tail, a knife-edge spike that seems to slant toward the sun. It is not a jet driving upstream. It's a view through a thin sheet, a stack of crumbs seen edge on, like looking along the grooves of a record, so that the grooves look like a single dark line. Shift the viewing angle a little, and the spike melts back into a fan. The sundial's lesson returns. Change the angle, and every shadow changes its length. Now fold in the sky itself. A bright moon raises the floor of darkness. Low altitudes thicken air and smear faint strands. Distant haze spreads city light into a pale wash. Under such conditions, the coma can feel obvious, while the tail hides at the threshold where signal and background trade whispers. On clearer, darker nights the fan lifts, the filament sharpens, stacked images recover faint arcs that a single exposure would have let go. Patience is not just a virtue here. It is a tool with measurable gain. The ion tail has its own weather. The solar wind is not a static breeze. It gusts and turns, and its magnetic field can flip in traveling sectors. Sometimes that causes a disconnection event. The ion filament breaks and reforms farther downstream, as if the taut string was snipped and instantly retied. To see it, you need luck, clear hours before and after a solar change, and a modest stretch of time so the pattern appears, then settles again. The dust fan hardly notices. It remembers hours and days, not minutes. Observers tease apart these structures with filters that favor certain molecules or reflect particular colors. Narrowband images make cyanides violet, carbons green, or sodium's yellow, speak more clearly, each adding a layer to the map. Polarizers help too. Dust scatters light in a way that rotates its polarization a little, and that twist hints at grain size. A spectrograph slit samples the glow and lays it into a ribbon where lines sit at known places. It all sounds technical until you remember the courtyard sundial. We are just measuring angles and brightnesses and letting geometry turn them into sense. Tail length is a living quantity. It grows as the comet nears the sun and more gas lifts more dust. Yet it also depends on where we stand, how the tail's plane is oriented, and how surface brightness spreads. A long, thin structure may be present, but too dim to separate from sky glow unless you stretch an image carefully or sum many short exposures. Activity can ebb or flare as a patch of fresh ice opens. Then dust settles back and the fan relaxes. No contradiction, only seasons within a single pass. A common question has a kinder answer than rumor offers. Why do some images seem to show a sunward spike? The reply rests on perspective and time. Dust lingers along the orbit behind the nucleus, and when we look nearly along that plane, the lingering becomes a line. The physics still points away from the sun. The apparent reversal is a trick of lanes and vantage, like the sundial's thin shadow lengthening at dawn, though the sun is rising the same way it rose yesterday. Short answer, softly said. A slanted ray looks stranger when you stand exactly in its plane. Photometry can confirm what the eye doubts. If you take radial profiles through the coma, the outer isophotes, curves of equal brightness, often stretch subtly in the anti-solar direction even when the fan is hard to see. In a raw frame, subtract the stars, a line on the moving point, and the elongation appears modest but real. On the best nights, larger instruments record the same direction more plainly. On modest nights, backyard telescopes still trace it statistically, and both kinds of seeing make one story. The slanted ray holds steady even when the courtyard grows dim. You may remember an image or two from a mountaintop telescope, the coma like a small cloud and a fan beginning to unfold. Another, later, under brighter moonlight, shows less. Yet the position angles agree, and the shape returns on darker nights. That constancy is the relaxing part. Tails are not omens, they are the sky's handwriting for familiar heat and wind. When the handwriting is faint, it is the paper, not a hidden motive. When it is strong, it is the same lesson writ larger. So keep the sundial nearby in your thoughts. Imagine the garden cooling, the shadow sliding another finger width along the stone, the slanted ray that marked noon now easing toward evening. Out over the rooftop, a pale fan lies away from the sun, and a pencil line points the same direction, each a different accent of the same push. The courtyard grows blue. The inscriptions on the face grow soft. We hold the moment a breath longer, a star-glow hold, and then we let it fade into night. Let's take a small trip without leaving the pillow. We start on a mountain road under thin air, a dome opening with a hush. Then we drift outward in thought, past clouds, past the blue, toward another lighthouse in the same night, the orbiter above Mars. Two watchposts, far apart, turning their beams toward one moving speck. Where the beams cross, a path brightens, twin beams crossing. From Earth, the visitor is a patient task. Point, measure, wait for the sky to turn. The dot inches against the fixed grid, and you write a line in the log. From Mars, the geometry is different. The dot slides at a slightly new angle. The parallax hop is larger. The same log gains depth. Stitch the two ledgers, and you no longer chase a blur. You follow a thread. It feels like walking a harbour at dusk and seeing the same lantern reflected in two piers at once, the ripples agreeing. This wasn't only a poetic moment. It was a procedural one. Positions derived from that Mars orbit camera were packaged like any other precise sky measurements and sent to the central clearinghouse where such things belong. The ledger accepted them. With that act, a door widened. Off-world vantage folded into the common chart for a traveller not bound to our sun. The phrase may have been short on the page, but it stretched easily across the quiet room where people make ephemerides. Why does it matter in the hands of a tired observer? Because aim improves. When a path shrinks from a thumb's breadth to a bead, you center a narrow slit on the first try. You commit a precious block of dark time without hedging. You plan an exposure to catch delicate gases before dawn erases the contrast. Across oceans, other domes benefit too. A plan posted before midnight becomes a near certainty by morning, and schedules click into place with less waste. Twin beams crossing save minutes, and minutes invite better data. It is also rehearsal, the best kind, quiet, successful, and remembered. An orbiter not built for comet hunting became a second eye. Analysts tuned their tools to follow a moving target rather than a planet's limb. The world's clearinghouse adapted formats to welcome a new vantage. None of that wakes a sleeping child, but it will matter again when the next difficult object skirts the sun's glare and half the telescopes on Earth need a tighter map by nightfall. Practice lives in the bloodstream of craft. It breathes even when no one cheers. Think of the baseline itself. Hold a thumb in front of your face and glance from one eye to the other. The hop you see is depth, made visible. Stretch that baseline from one world to the next, and the hop yields distance and direction with a kindness you can feel in your shoulders. The target is where the math says it will be. The motor drive follows smoothly. The guiding graph stays calm, a small line wandering within bounds. Even a backyard rig, guided by fresh coordinates, slews confidently and begins to stack frames while the tea is still warm. There is a human picture behind the numbers. A flight dynamics team times a pointing window between routine Mars work. A camera team reshapes its pipeline, teaching it to recognize a faint tuft, moving on star fields instead of dunes and craters. At a desk on Earth, an orbit computer merges that stream with last night's mountain data and updates a plain table. Time, coordinates, uncertainty. Down the hall, a scheduler glances at the tightened figures and frees a second instrument to chase something else at dawn. Each step is small. Together, they lift weeks of work a few quiet millimeters closer to perfect. The twin beam picture brings more than position. It helps with pace. When a comet's activity ebbs and flows, when its fan thickens or a slim filament flickers in and out, observers need repeatable framing so that differences between nights reflect the sky, not aim. Geometry from two shores steadies that framing. You can compare spectra line by line without worrying that last night's slit sampled a different slice of coma. You can test for subtle twists in polarization with less fear that the angle drifted off your mark. It feels like stepping onto a boat whose deck barely moves. It is tempting to treat all of this as exceptional, a one-off alignment of tools and luck. Better to see it as normal, written forward. Planetary orbiters watch their worlds for years. Some nights, one will be in the right place to lend its angle to a passing guest. Some teams will remember the gentle script. Request, a look, a line. The clocks format the measures, send the note to the ledger. We'll call it coordination when it happens again, though the work itself will look much like tonight. Steady, undramatic, effective. And for the listener slipping towards sleep, a simpler image holds enough. Two lighthouses on different capes sweep the same reach of sea. Their beams do not flare with urgency. They turn at their measured rates, cross softly on a small boat, and keep going. With each pass, the wake looks straighter, the channel more sure. That is the feeling the numbers brought, the way a hand relaxes when a line on the chart becomes thin, then thinner, then exact enough that no one needs to raise a voice. Twin beams crossing. Then the scene cuts to dark, like a lantern snuffed between breaths. Picture a grand library after hours. The lamps are turned low, A velvet rope crosses one gallery, a few reading lights stay on at selected desks. Pages still turn softly where they must, while other rooms wait. That is how science looked during the recent pause, dimmed in places, steady in others, with caretakers moving quietly so nothing vital sleeps unattended. At the start of October, the US government entered a shutdown. Agencies drew up their continuity plans, and NASA placed most civil servants on furlough while essential work, spacecraft health, the International Space Station, deep space communications continued. Observatories that depend on NASA pipelines saw some tasks slow or queue up. But the sky did not stop, and neither did every lamp in the library. Across the ocean, partners kept their sections open. The European Space Agency continued routine operations, and in mid-November published cross-planet measurements that helped refine the path of our interstellar visitor, even noting that Mars-based astrometry had been accepted by the Minor Planet Center. That update read, like a librarian's neat card, slipped into the common catalogue. New entry filed, shelves aligned, reference strengthened. The story moved forward without fanfare. Back in Washington's long corridors, a bill moved toward the president's desk. On November 12th, the shutdown ended. NASA posted the simple notice that matters most to the people who tend our spacecraft. The agency is open. Normal operations have resumed. The rope across the gallery lifted. Lights came back up by rows. The backlog carts began to roll. Quietly, the pages started turning faster again. What happens after the doors reopen is less dramatic than headlines suggest, and more human. Teams return to email inboxes that feel like tide pools after a spring storm. Data waits in buffers. Scripts that would have run last week run today. Instrument specialists compare notes with partners who kept working while they were away. None of this is a sprint. It is a careful shelve and sort, the way a good librarian restores order after a festival night. The result is not noise, but clarity, more hands to proof, more eyes to check, fits, more time to answer the "could you look again?" messages from observers who held the line in the dark. For 3i Atlas, the practical meaning was simple. Geometry kept improving as it moved away from the sun's glare. Ground telescopes could steal longer looks at dawn and dusk. The ESA update from Mars, already in the ledger, gave everyone a tighter bead. When NASA's desks lit again on November 12th, analysts could stitch those threads to their own spectral and imaging cues, polishing the ephemeris and aim plans that December observing runs will need. The library metaphor felt exact. The right books returned to the right shelf, just in time for a long-reserved reading table. It helps to remember that a global science effort is genuinely global. Some instruments are funded nationally but serve internationally. Some are international by design. When one center dims, others stay bright, and the fabric holds. For sleep, what matters is not which hallway was dark last week, but that the building itself stayed open somewhere, that the card catalogue kept breathing, that the stitched map on the wall kept its shape. There will be lag in a few places. Some public image releases push by days. Some peer-review timelines pick up mid-stride. A planned calibration might slide to the next clear night. But none of that touches the part of the story that calls for rest. The distances remain wide. The observations accumulate. The patient craft of measuring faint things against a steady sky continues. The pages turning softly are the sounds of continuity. If you felt tension during the pause, let the dates settle it. Shutdown began in early October. On November 12th, the government reopened. NASA declared itself open and returning to routine operations. ESA's mid-November notes about off-world astrometry stood ready to be folded into common practice. Taken together, those are library stamps that tell you what shelf to trust. The stamps say, this chapter goes here, this next to it. No pages missing. And if part of you still worries that delays mean secrets, breathe out. Most of what resumes after a pause is ordinary. Processing raw frames, comparing brightness measurements, filing coordinates, proofreading captions. It is hard to hide drama in a room full of page number checks. The watchword is consistency more than revelation. We sleep well, not because mysteries are solved in a day, but because the ledgers balance and the lamps come back on. So imagine the library again. A custodian wheels the rope away. A supervisor tilts a bank of lights to warm. At a table near the window, two scientists put their notebooks side by side and quietly match figures. Outside, the night is the same as it was yesterday. Constant, enormous, serene. Inside, the breathing of the building slows to its usual pace. We exhale, count to 4, and let that pace carry us onward. Numbers can be a lullaby when they move like breath. So let me read a gentle list the way a station agent might call departures at midnight. Dates that are windows, angles that are friendly, instruments that listen without fuss. We're talking about the faint ribbon an ion tail lays along the solar wind, how the stream might carry that ribbon across places where our receivers wait. Voiceover of figures, calm and slow. An ion tail is a signpost in moving air. Charged molecules, born when sunlight breaks water and other ices, get swept into alignment with the magnetic field frozen into the solar wind. The result is a long, slender streamer pointing away from the sun, straighter than dust, bluer to a camera's eye. Where the wind goes, the ribbon goes. Change the wind, and sometimes the ribbon snaps and reknits farther downstream. Sailors would call that weather. Physics calls it field topology and reconnection. Either way, its motion you can almost hear if you listen for the softest hiss. Because the ribbon rides the wind, there are nights when geometry turns gracious. A line from the sun through the comet can extend across millions of kilometers, and if Earth, or a spacecraft near Earth, sits along that line of flow, the ribbon can pass over us like a thin, invisible streamer. The crossing is not a hit. It's a brush of ions in a river already around us, the solar wind we bathe in every day. What changes is flavor and fine structure, a faint enrichment in species, a twist in the magnetic field, a whisper of pickup ions riding past. These are the sorts of signatures instruments love to catch when prediction says the streamer might pass here. Predictions are published as windows, not promises. They look like little blocks on a chart, hours when the Sun-Comet-Earth alignment and the modelled wind would plausibly carry the streamer our way. They can be wrong by a bit if the wind bends or if a coronal mass ejection arrives to jumble the lanes. But as waypoints, they're useful. Observers cue spectrometers and magnetometers to sample steadily through the window, so that if a dip or spike arrives, it lives inside the record. It's like setting a microphone to capture the night train, whether it comes at 12:05 or 12:15. What listens? In space, magnetometers aboard many missions keep time with the wind, reading its field lines as if they were strings. Particle detectors measure the energies and masses of passing ions, hydrogen, helium, oxygen, carbon-bearing fragments, so a streamer rich in comet-borne species can be picked out from the solar background. Mass spectrometers on planetary orbiters, when geometry cooperates, can taste dust and gas that drift through their neighborhoods. Closer to home, ground-based radio arrays can look for subtle absorption against background sources when trace gases pass between us and those beacons, while optical spectrographs track the rise and fall of emission features that brighten when fresh ions flood the tail. The toolkit is varied, the temperament is patient. A favorite example, just to hold the idea. When a narrow tail filament crosses our line of sight, a magnetometer might log a gentle rotation in field direction, tiny, but matched to the predicted hour. A particle instrument could show a few minutes of enhanced counts at energies that fit newly born ions, being accelerated by the wind. A telescope, watching in a narrow band suited to a particular ion, might see the tail's brightness pulse, then relax. Each on its own is small. Together, they sketch a ribbon passing by. Past comets taught the method. We've seen ion tail disconnects tied to changes in the solar wind. We've sampled cometary gases near planets when a visitor brushed close. And we've watched cameras aboard heliophysics missions capture long blue streamers kinking and reforming after solar storms. Those aren't this comet. They're proof-of-concept lullabies, evidence that the sky does write in this script, and our instruments can read it. With 3i Atlas, the same alphabet applies, only the timing and geometry change. If you'd like a picture you can keep with your eyes shut, imagine a row of wind streamers tied to a fence. They all lean the same way in a steady breeze. One is longer than the rest. That's the ion tail. Far down the field, a train passes. Its wake jostles the fence, and one streamer lifts, wobbles, and then settles back. If you had a slow camera, you'd see the wobble. If you had a microphone for wind, you'd hear a faint flutter. Astronomers put both kinds of senses on the fence and wait for the flutter to come through. Windows for possible crossings are not the only way to listen. The ribbon can also sweep across other spacecraft scattered through the inner system. A probe near Mars, a solar observatory inward of Earth, or a watchful orbiter in a different longitude might be brushed first. When one detects a change, alerts ripple outward, and other instruments dig into their data around the same hour. This is how 1,000 weak clues become one strong line, triangulation, not of place this time, but of time. The faint ribbon writes the same tick on several clocks, and confidence grows. The practical advice for sleepy minds is gentle. Windows are invitations, not alarms. If an observatory doesn't catch a signature on the first try, the loss is small. The river is always moving, and more ribbons pass in the weeks after perihelion as the comet continues to shed. Where windows do coincide with clear skies or a quiet space weather day, the reward is a neat line in the log. One more modest data point that helps decode how interstellar ice behaves under our sun's wind. Small stitches make a strong cloth. It's easy, amid lists of instruments and hours, to forget the bedside value of the exercise. It is not to raise pulse, but to lower it. Forecasts exist so that night crews can prepare without haste. Crossings, if they come, are measured events in a medium we live in continuously. The solar wind is our weather and our long-term companion. A visiting ribbon woven into that wind is a change of colour, not a gale. Mark the window, take the data, brew more tea, then sleep. The wind keeps blowing, and the ribbon keeps its course, whether or not we are there to watch every minute. Now hear the station agent again, low and clear. Window opens, instruments ready, expected duration short. The platform clock ticks. Somewhere under the stars, a fine streamer leans farther downwind, then glides past unseen rails that tie our monitors together. On your pillow, the numbers recede like tail lights along a valley. The night train hum fades in the ribs of the house. The faint ribbon is out there, and we'll read it in the morning. Hold a paper calendar in your hands. It has that smooth, slightly fibrous feel, and someone, maybe you, maybe me, has drawn a small penciled circle around a square in the middle of December. The circle isn't urgent ink. It's graphite, soft and erasable, a reminder more than a command. On that day, our visitor slides to its nearest distance from Earth. Nearest is a word that can startle, so we pair it with scale. The gap stays wide, measured in the long reach from us to the sun, and then some. The hearth calendar sits by a lamp. The penciled circle glows a little in that warm light. What does the circle ask of us? Almost nothing. It offers a window. Around that date, geometry improves. The object eases from the sun's glare, climbs a bit higher in twilight, and lets careful instruments take steadier aim. That is all. The page will not flip faster. The tides do not change their mind. The story remains a slow, quiet arc across a very big room. For observers, a circle on the page becomes a plan, written in low letters. Professional teams reserve time slots, compare weather histories, and ready spectrographs and polarizers. Volunteer networks check the ephemeris, distribute fresh coordinates, and remember where last month's tests left off. The rhythm is measured. Dawn runs for some, evening runs for others, stitched into a web that wraps the planet. No one instrument has to do everything. The sum does the work. The penciled circle is simply a polite nudge to pack the thermos and sharpen the focus routine. If you prefer your sky from the backyard, the circle has a gentler meaning. It says, if you happen to wake early, you might step outside for a minute and let your eyes go wide. You may not see the traveller. Few comets look bold without binoculars or more. But the air will be clean at that hour, and familiar stars will keep their places. Somewhere along that dome, small telescopes will be stacking 30-second exposures, letting the faint glow rise through patience. You can imagine those stacks the way you imagine loaves rising under clean cloth. Warmth does the work. Time does the rest. Amateurs who like a challenge will follow the circle with craft. A solid mount, careful pointing from a fresh ephemeris, short exposures, repeated often, then registration on the moving point, so the stars blur and the comet holds still. That's the recipe. 12-inch mirrors make it easier. Smaller instruments can help if the sky is dark and the workflow unhurried. A narrowband filter might lift a whisper of ion light. A plain luminance frame might best catch the dust fan. None of this is required to enjoy the night. The sky isn't a test. It's a porch you can sit on. And if your porch is clouded, the penciled circle still offers company. Some observatories stream their sessions or post-captured stacks after the shutter closes. A familiar project in Italy has a habit of inviting the world along, turning raw photons into a shared quiet. The comment threads there, red, like a late-night cafe. People from far longitudes trading "I see it" and "clear skies," while a faint tuft moves across the field. Knowing that others are awake beneath the same calendar square can be enough. You sleep, they watch. The story goes on. On the big wall map in my head, I draw another circle, this one stretched across the planet. Arrows radiate from it. Chile's ridges, Canary domes, Arizona mesas, South Africa's Karoo, Australia's inland dark. Each adds a line to the ledger when its night arrives. When those lines are laid over each other, the image deepens. What was barely a smudge in one place becomes a confident smear in another. What was silent in the blue of evening becomes a clear whisper in the black of pre-dawn. Coordination turns those small gifts into a full page. The penciled circle earned its space. Dates calm the mind when they're true and few. Perihelion, late in October. The closest to Earth Day in the middle of December. After that, a slow outward drift, brightness easing back as the sun's heat slackens. For listeners tucked into quilts, that's the cadence to hold. A front porch light brightening, then dimming, with no one coming up the steps. If the numbers insist on being thought about, tuck them into breath. One long room, an astronomical unit per inhale, another per exhale. In a handful of breaths, you've crossed the distance and back in imagination. The house stays still. I like the domesticity of the thing. A calendar by the kettle, a circle around a day that promises a little extra clarity for the people keeping watch. A note in the margin, early window, try again tomorrow if cloudy. The world is full of loud arrows and urgent stamps. This one is pencil, and the lead wears down pleasantly as you write. The lines it leaves are clean and quiet. They remind you that the heavens move at a humanly survivable pace, one that tolerates rain checks, welcomes repeat attempts. When the day arrives, nothing sudden happens. Somewhere a door unlatches on a dome. Somewhere a spectrograph lamp warms. Somewhere a backyard tripod steadies on cold pavement and a gloved hand scrolls to tonight's coordinates. The comet is where the ledger says it will be. Frames accumulate, notes are made, and the penciled circle fulfills its promise. Not an event, but a window. As the session ends, screens go dark, coffee cools, and the night withdraws like a low tide, quiet, slow, leaving the sand smooth and untroubled behind it. A night watch has rituals. Before the lights dim, we walk the deck of our quiet ship, touch each instrument with a glance, and sign the log with an even hand. The sea is calm, the stars are steady, the pencil writes without hurry. Tonight's log is simple. It lists what we have in hand, what we expect to gather soon, and what can sleep until morning. First, what we hold. A traveller, third of its kind we've known, follows a hyperbolic lane, an in and out sweep that does not close. Radio ears have heard water's child in the coma, two soft notches where hydroxyl drinks a little from background glow. A camera circling Mars contributed angles that shrank the search bead tenfold, and the ledger accepted those measures alongside Earth's. Geometry is kinder now. Dawn and dusk offer longer looks. The calendar carries a penciled circle in mid-December that means window, not alarm. Distances remain deep water calm. Next, the nearby companion in our story, a faint, steep-tilted comet with a discoverer's familiar surname, moves along its own quiet track. Some nights it shows a stubby tail. Some nights the veil stays close. It shares our balcony, but not our path. 2 boats, 1 horizon, miles between. That's enough to let the mind unclench. Now, what we hope to add as the nights unwrap. Spectra that sort dust from gas with finer teeth. Polarization angles that whisper grain size. Timed photometry that hears rotation. If the nucleus turns with a rhythm strong enough to imprint the halo. Narrowband images of the faint blue filament when the wind leans right, and perhaps the brief flutter of a disconnection event if the solar weather obliges. No single measurement needs to carry the weight. Many small stitches, neatly spaced, make the cloth. We also name what we do not need. We do not need grand pronouncements while the ledger is still receiving pages. We do not need the heart to race because a tale seems shorter under moonlight, or a line is hard to see at low altitude. The sky is large, the instruments numerous, and patience is a tool as real as glass and aluminum. When the geometry hides, we wait for it to turn. When the wind tangles, we watch until it smooths. I keep a picture to make this plain. Imagine a low-lit workshop at midnight. On a felt-lined tray, calibrated tools rest in calm rows. Spectrograph slit jaws, a polarizer wheel, a stack of finder charts, a thermos cup that still holds a little warmth. On the far bench, a small red light glows, where an exposure ticks along. Nothing in the room aches to be faster. The work is precise because the pace is. This is the workshop that measures comets kindly. We honor how ordinary mechanisms make the beauty. Sun warms ice, gas lifts dust, light and wind push outward. A curved fan, a straight filament, a round halo. Handwriting we've learned to read. Interstellar origin adds an accent, not a threat. Off-world angles add clarity, not drama. Even the radio notch is a home truth repeated in a new voice. Science is a chorus. Tonight's song uses familiar notes. If uncertainty peeks over the sill, give it a chair and a blanket. Let it sit while we finish the log. Here is the closing posture. We will continue to measure softly, mark what is seen, cradle what seems likely, and set what is not yet known on the shelf labeled later. We will welcome fresh data from mountains and orbit, fold it into the chart, and draw the thin white line a finger-width farther each day. No urgency attends this, only craft. Before we close, breathe with me once more. In for 4, out for 6. Picture the fan leaning away from the sun. Picture the filament as a taut blue thread. Picture the halo as a lantern held in cupped hands. Far beyond, picture Mars as a second pier with a steady lamp, and Earth as the first pier, both lighthouses turning in time. Where their beams cross, a path brightens. Where patience settles, sleep follows. The last act of a night watch is simple. We cap pens. We switch the monitor to its dimmest red. We note the weather, the time, the state of the instruments, and a small one-line hope for tomorrow. Then we latch the window so the cool air stays cool and the room stays still. The click is tiny and kind. The ship keeps its course. The sky keeps its slow, luminous writing. We keep the log, and the night keeps us. We have walked quietly together through a long, calm night. A visitor from beyond our sun traced an open path, and we let steady instruments show us gentle truths. Water's child heard in radio, a thin blue filament shaped by the wind, a halo that breathes with distance, a path refined when Mars lent its angle. Another fainter traveller crossed the same wide sky on its own course, a sidelight that did not tug our main thread. The distances remained generous. The calendar's circle marked a window, not a warning. In every scene, the same pattern held. Small measures, repeated with care, stitched a clearer map. Radio dips at known pitches, images stacked until faint tails rose above the floor. Coordinates tightened when two lighthouses crossed their beams. The language was ordinary and kind. Observe, compare, refine, rest. As you drift now, carry the soft images that do not ask for effort. A lantern cupped in hands, a slanted ray across, a sundial, twin beams sweeping the same reach of sea, a penciled circle by the kettle, a window latch clicking gently at the end of watch. These are enough to keep the mind quiet while the body chooses sleep. Thank you for keeping me company while the sky wrote its slow, luminous lines. May your breathing find its even tide. May your room hold its hush. Out beyond the roofline, the visitor continues on, untroubled, and our instruments keep their patient vigil. We will meet it again in the morning, if we like, or let it pass into memory as a soft, bright lesson in how to look. Good night.